Hi everyone. So today I'll be recording my first screencasting of the contest Div3. Since this is my first attempt, I don't know how I'll do, but I'll try to go along slowly and explain all of my solutions. So the contest starts in 1 minute. Let's see how the questions are. It is the first contest of 2021 on Codeforces. I think I have everything set up. Yeah. Let's see how many questions this contest has. So this contest has 7 questions. The name seems interesting, even not game. So anyway, the first problem. For the New Year, Polycarp decided to send postcards to all of his friends. He wants to make postcards with his own hands, and for this purpose, he has a sheet of paper of size W cross H which can be cut into pieces. He can cut any sheet of paper W cross H that he has into two cases. That is, if W is even, he can cut it in half to get W by 2 into H. Two sheets of size W by 2 into H, and similarly if H is even, he can cut the sheet in half and get two sheets of size W into H by 2. So basically we can cut the sheet along the length or the breadth, assuming that the length or the breadth is even depending on where we are cutting it along. And if they are both even, then we can cut according to any one of the rules. Yes. So after cutting a sheet of paper, the total number of sheets of paper are increased by 1. That is obvious. So we want to find out if we can cut the sheet of size W into H into n or more pieces using only the rules described above. Okay. So the first thing that comes to my mind is obviously that I need to find the maximum number of pieces that paper W into H can be cut into, because if n is less than equal to maximum number, then the answer would definitely be yes. Otherwise it would be no, because I can always stop cutting the sheets into various other sheets once I have the required number of pieces that I want. So what can we do in this case? I think a simple recursion, a brute force approach would work. Let me see. So what I'm thinking is, first I take the input. I have W, H and N, and I want to find the maximum value of the pieces that I can cut it into. I think it would be right to assume that, yeah, I think like a basic brute force recursion would work. So basically I recurse on W cross H, and if max is greater than equal to N, I print yes, otherwise I print no. And my recursion would basically be, if W is even, then I return 2 into recurse of W into H by 2, because I have two sheets and I can perform the same operations on both of them. And similarly, if I have H mod 2 equal to 0, then I can do recurse of else if, okay, yeah, I don't think it matters. Yeah, I can recurse on W comma H by, sorry, this should be W by 2 comma H. This should be W comma H by 2, and if both of them are even, then I cannot do anything, so I return 1. So I think this should work. Yeah, it works on the sample, so I'll submit it. Yeah, that gives AC. So the reason I like this works is because we will be dividing W at most log of value number of times, and similarly we would be dividing h at most log 2 of h number of times, and the values are very small. I think what 2 raised to 20 is 26, 2 raised to 10, so basically something around 14 times. So I have 2 raised to 14 as in that's, yeah, I need 2 raised to 14. So basically I can divide it along the height 14 times, I can divide it along the width 14 times, and basically I can multiply the number of divisions I get. Okay, so now the fair division. Alice and Bob receive N candies from their parents. Each candy weighs either 1 grams or 2 grams. Now they want to divide all the candies among themselves, so that the total weight of Alice's candies is equal to the total weight of Bob's candies. Check if they can do that. Note that the candies are not allowed to be cut in half. Okay, so basically the question is that we are given an array of that contains 1s and 2s as the input, and we want to determine if this array can be divided into 2 subsets such that the weight of the elements in both the subsets are equal. So I have n is up to 105. So I'll take the input. So obviously the first condition is that the sum must be even, and among even sums I think the only case when it is not possible to divide, no, okay. So I think I should always, like if I have 2s, I would always want to divide them equally, right? Yeah, I think basically a greedy approach should work over here. So basically what I will do is I'll have some A initialized to 0, some B initialized to 0. I will sort the whole array, and then I will proceed from the back greedily. So if A has lesser, or like if sum A is less than equal to sum B, then I'll do sum A plus equal to A of I. Otherwise sum B plus equal to A of I, and in the end if sum A is equal to sum B, the answer is yes. Otherwise the answer is no. Yeah, it works, so I'll submit it, and then I'll explain basically why this works, or basically what was my intuition for thinking this way. So the reason is that if I consider elements that have weight equal to 2, it is never optimal to divide, suppose I have these two sets corresponding to A and B. If I give A one element 2, right, then I believe that it is never optimal to give another 2 to this person before giving it to B, because if I want to say, suppose I want to distribute it this way, and another way of doing this would have been that I give 2 to this beforehand and then I distribute the 1s equally, right? So basically that was my intuition basically. So basically I want to divide the 2s equally, and then obviously I would be giving 1 to the person that has lesser amount of elements. Then let's see the next question. So Polycarp found under the Christmas tree an array of n elements and instructions for playing with it. At first, choose index I from 1 to n, starting position in the array. Okay, put the chip at the index I, that is on the value AI. While I less than equal to n, add AI to your score and move the chip AI positions to the right. Okay, if I is greater than n, then Polycarp ends the game. So we want to find the maximum score that we can get. So basically, yeah, this is a very straightforward DP question or an implementation question where you basically memorize the values, because you can imagine that this question, every element in this question can be imagined as a node, right? And every node has one outgoing edge to, that is I go from I to I plus AI, and I just want the maximum summation path along this in this graph, right? So let me take the input again and I'll show you what I'm doing. So basically what I'll be doing is I'll simply be recursing and storing the value. So suppose I'm on some index. The question says that if I cross n, then I return 0, right? That is, I cannot take any more elements. Otherwise my value is simply int, and I also need a visited array. So let me say this is all of the initial elements are not visited. So if I have visited this index before, then I can simply say that the value is whatever I got last time I visited it. So suppose it was cache of n, so return cache of index. Otherwise I mark this element as visited and I store the value. So cache of index is equal to a of index plus dp of I'll try to keep a track of when it stops recording, and possibly after the contest I'll try to debug why that is happening. So anyway, question problem D, even odd game. During the new holidays, Alice and Bob play the following game using an array of n integers. Players take turns. Alice moves first. Each turn a player must choose any element and remove it from the array. If Alice chooses an even value, then she adds it to her score. If the chosen value is odd, Alice's score does not change. Okay. Similarly, if Bob chooses odd value, then he adds it to his score. If the value chosen is even, then Bob's score does not change. So our aim is to find out who wins the game. So in this question, I think it is very straightforward that I can just sort the array and both of the people would be trying to take the largest value, because if suppose it is Alice's turn and the largest value is even, then it obviously makes sense for her to take that value. If that value is odd and suppose Alice chooses some element less than that maximum value, right, then she's getting some smaller value added to her score, whereas in the next turn Bob can choose that largest value and add it to his score, and that would basically increase the difference of values that they would have. That is, Bob's score would increase, because let me show what I mean. So I have some sorted array, right, a1 to an. Alice is leaving an, so she's choosing some aj, some ai, right, and then Bob can choose an. So after this turn I have some new array a1 to an minus 2. Suppose this array is sorted, then I have a new game, and already I can see that Bob's score, like the score difference, Bob minus Alice, that is an minus ai, is greater than equal to 0, right? So I think like it makes sense for Alice to remove an irrespective of whether it was odd or even. If it is even, she can add it to her own score. If not, then she would basically be preventing Bob from taking that value. So let me see. What is the player with the high score wins, right? Okay. So let's simply sort the array, and I have this difference. If it is, what if it is a tie? Then a draw is declared. Okay, fine. So I start from the largest value and I store which player's turn it is, right? So okay, turn is 0. If turn is equal to ai and 1, right? So ai and 1 is basically if that element is odd. So yes, so if the turn matches the parity, then depending on the turn, if it is odd's turn, then if it is Alice's turn, then I will add the difference. Otherwise, I will subtract the difference. And in other cases, I don't have to do anything. So if difference is positive, then Alice wins. Else, if difference is negative, Bob wins. And lastly, if the difference is same, that is they both have the same value, then it is a draw, obviously. So I have a tie. I really hope it does not stop recording randomly. Okay, why is it saying Bob, 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 Bob? For 3 to 1, Alice can take 3, Bob will take 2, right? Okay, I'm not changing the turn. Turns are equal to 1. So I have Alice type, Bob, Bob. Okay, that is opposite, right? So let us consider this case. I have 3 to 1, and who is starting the game? Alice moves first, and Alice chooses even value. So in this case, Alice will remove 3. Then Bob will remove 2. Okay, so basically neither of them are taking the values. So why is this happening? Alice will always take even values, right? Okay, so I got that was correct. So all of the other cases are wrong. Okay, so let me consider the last case. I have 7 and 8. So Alice will choose 8, right? Okay, if turn is equal to 0, sorry. Yeah. Okay, I think there is a queue. The last judge submission is at 16:00, so very small queue. Yeah. So yeah, that is correct. Let's see. E has been very less solved comparatively as compared to F, as compared to D. I think the implementation might be long. F is even weirder. Okay, so let's see. Problem E. Polycarp has invited n friends to celebrate the new year. During the celebration, he decided to take a group photo of all his friends. Each friend can stand or lie on the side. Each friend is characterized by 2 values, hi and wi, that is their height and the width. On the photo, the ith friend will occupy a rectangle of hi cross wi if they are standing, or wi cross hi if they are lying on the side. The jth friend can be placed in front of the ith friend in the photo if his rectangle is lower and narrower than the rectangle of the ith friend. Formally, at least one of the following conditions must be satisfied. That is, if both of them are standing or both of them are lying, then height and width should be less, otherwise the opposite. Okay, that is fine. So if I have n equal to 3 and heights and widths are 3, 5, 3, 4, 4, 3 respectively, then the first can, okay, I'm not going to look at the example. So in other cases, the person in the foreground will overlap the person in the background. Help Polycarp for each I find any j such that jth friend can be located in front of the ith friend. That is, at least one of the above conditions is fulfilled. Notice that you do not have to find the arrangement of all the photos. You just need to find for each friend I any other friend j who will be located in front of him. Think about it as you need to solve n separate independent problems. Okay. So what I'm thinking is, in this case, what I can do is, firstly, I will assume that neither of the people are swapped. So basically, they're all either standing or they're all either lying on the side. So in this case, I just need to compare the height values and the width values. So let me construct a struct which will store the values that I need. So I need width, I need height, I need index, right? And I have n. I have some struct data of values and I need a comparator. So I don't know how many comparators I need, but let's see. Okay, so I'll type def this because C++17 gives an error if we do not type def the struct and directly use the name. So struct type def struct node as data. Okay, so now I have data of n and I pass these data points by reference. So let me take the input first. So I have cn of n. I take a of I dot h, a of I dot w, and a of I dot index is obviously equal to I, and I consider the first case, that is neither of the friends are swapped. Basically they are not changing, like neither of the friends is rotating, or both of them are rotating, right? So yeah, so in this case what I can do is I can simply sort all of them by height first, and then okay, so let me first sort them by height. So if d1.h is not equal to d2.h, I put the one with the less height first, otherwise I put the one with the smaller width first. I need to say that I can be located in front of the ith friend. Okay, yeah, that is fine. So now, since I have sorted the array by height, right? So I have this array that is sorted by height, h3 till hn, and I have their respective widths till wn. So what I need is, like, I know for some hi there will be a prefix of values that will always be less than hi, and among them I can directly always take the value with the least width. If that value satisfies the condition, then I have the answer, otherwise it is not possible. So yeah, so basically I can have something like a 2-pointer. Suppose my right end point right now is this person, right? I iterate from the left end, and yes, so let me store the answers globally for every index. So initially all of the answers are -1. Now what I will do is I will increment my left pointer as long as it is less than equal to the right end point, not less than equal to, less than the right end point, because the person has to be someone else, and obviously a of l has to be less than a of r. If this is true, then I can basically, what I'm doing right now is for every element in the array, suppose I'm at hi, right? So hr, I'm trying to find the largest index hl such that hl is less than hr, and among these values I need the one with the minimum width. So current minimum is what, 2e9, and current index is suppose -1, right? Yeah, so I will increment my pointer. I will, if a of l is less than current minimum, right? So then in that case I can replace the current minimum by a of l, and I can replace the current index by a of l dot, okay, a of l dot w is less than current min. And over here I should have been comparing heights, my bad. Yeah, so I replace it by the minimum width, and I replace it by the original index of that element. So now for every index a of r dot idx, I store the answer as current index. So now I have the answer for elements. I have some answers, and some of the answers may be -1. I need to consider the other case, that is the elements are swapped, right? So again in this case, instead of, like, basically what I'm doing is for every element I am assuming that the jth element is swapped, or I'm myself and swapped and they are not. So basically that is again the same case, that is I either swap myself or I swap them. So obviously it does not make sense to swap all of the other elements in the array. I will consider that I am the one who is being swapped, and I want to find the answer for every other element. Okay, so basically, yeah, so what I'm trying to do is, again I have this sorted array, and for the ith element, what I want to do is I want to swap hi comma wi, and I want to find the answer, and then again I swap them back. So like everything stays the same, just I want to find the answer for swapped hi comma wi. Okay, so basically if current minimum is less than a of r dot w was the necessary condition over here. Yeah. And now what can I do? So how do I find the answer, right? Okay, I think that is very easy. So instead of 2 pointers, if I had initially stored a prefix minimum of these values and these values, then I think I would have had the answer, right? So yeah, so basically what I'll do is I'll store the prefix minimums. Yeah, so I have prefix min. I initialize prefix min of I by 2e9. Prefix min of 0 will always be 2e9. And now what I can do is, when I'm computing this, I can also keep on storing the prefix minimum. So I have prefix minimum of i's, minimum of prefix minimum of I comma. Okay, instead of doing it like this, if a of r dot w, if my current weight is less than the previous minimum that existed, then I have prefix minimum of r equal to a of r dot w, else prefix minimum of r is same as the prefix minimum of that was same so far, right? If my current weight like that, and I need to store the index that it is coming from, so min idx of n. So again I'll initialize this by 1 just for a sanity check, and min index of r is equal to min index of r minus 1. Otherwise I'll also update the minimum index, so I'm getting the minimum value from myself, right? Yeah, okay, not myself, basically the original index e of r dot idx. Yes, yeah, so now I can repeat the same algorithm, but now I don't even need 2 pointers, but I let that algorithm be there just to show an alternative method of implementation. Yeah, so now what I want to do is, when I'm at the ith element, so I have my current height as a of I dot w, because I'm actually swapping hi comma wi and comparing with the prefix. Okay, again there will be an issue, because if this w is big, then I might end up using my own value as the minimum. Okay, I don't think that is an issue. I don't think that should be an issue. Yeah. So I'm swapping hi comma wi. Yeah, so I want to find the largest element in this array that is less than equal to, that is in fact less than, right? Okay, so for this current height, I find the iterator that is lower bound in a plus 1 comma a plus n plus 1 of data current dot height will be current dot weight will be a of I dot h, and current dot idx will be a of I dot idx, and I want to find the lower bound of this. So this should work for the lower bound, and then I will, like, if it equal to 1, then I can just continue. That is, there is no element that is smaller than this. Otherwise, I can directly use the minimum value. So index is it minus 1. If prefix minimum of, I'm still concerned that I might end up using my own value. How do I prevent that from happening? I don't want to use my own value. swapped. I get some large H. This W. I'm actually thinking that in this problem it might be beneficial to always swap L comma B if L is less than B. Is it ever optimal to use L greater than B for one index and L less than B for another? I don't think it ever makes sense. So instead of all of this, what I can do, I think what I can do is, if A of I dot H is greater than A of I dot W, I can swap them. Hopefully this should be correct. I don't need to do all of this. Oh, sorry. Yeah, I don't need to do this. And I can remove these arrays. So this is what the answer should be according to me. Let's see. I really hope this is not wrong. Prefix, okay, I need to sort them with the comparator. Prefix min is not required. Yeah, not required, and this is also not required. 3, 3 minus 1. So for this, I am saying the answer is 3. But my L should not have gone that far, right? Because I'm ensuring that my height is always less. So basically in my case, the arrays are this. After sorting them, I basically get this, right? So I don't know what is happening. Let me see. A of R, what is the current min, right? Wait, what? I got minus 1, 1, 1. H is greater than this. I swap. Oh, sorry. Wait, what is happening? So I have 3, 3 minus 1, right? What if I take this value and I make it 4, 5? Should my answer change? Yeah, it's not. So suppose I rearrange this. Why is my answer changing? This is exactly what my comparator should have given in the first place. So if d1.h is not equal to d2.h, I return d1.h less than d2.h. Okay. Otherwise, I return d1.w less than d2.w. Okay. Let me see. A of I dot h space A of I dot w. I have 3, 3, 3, 4, 3, 5. What about this? 3, 4, 3, 3, 3, 4, 4, 5. Yeah, that is fine. So what is happening? I sorted them, right? I don't need to check this condition anymore. I have here A of I dot h space A of I dot w. Three, 4, 3, 3, 3, 4, 4, 5. Okay. What if I make it this? 3, 3, 3, 4, 3, 5. So I think there is some undefined behavior because obviously the array is the same. So let us see what's happening. I have here for this R, I have L as this and current minimum is this. Let's see. Okay, so for the second index, current minimum is 3. But why did the current minimum change? If L plus 1 less than R and A of L plus 1 is less than A of R dot H. Sorry. So now for this index, yes, I can store one. Yes, so that seems correct. So I have -1 T1 -1 -1 1. Okay, so far I can use this. Yes, T3 -1 3. Yeah, that seems correct. Did I remove all the seers? Let me see. No, I did not. Yeah, that seems correct. I'll submit it. That took a lot of time. 19 minutes. Again, there's a queue. I'm at 34 something. The judging time is at 35, 38, 35, 36. I got compilation error. I had typed def, right? Okay, screw G++ 17. But seriously, why? I typed def this. So I don't think it should have given an error, but I'll debug it later. It's definitely a struct issue. Error reference to data is ambiguous. Probably should have named it something else. Yeah, so that is AC. What's my rank right now? Okay, people have solved G. Let's see, I have F and I have G. F seems to be more harder. Is it more implementation or what? G is more solved. Okay, so even I'll check G first. So moving to the capital, there are n cities in Berlin. The city number 1 is the capital, and some pairs of cities are connected by a one-way road of length 1. Before the trip, Polycarp for each city found the value of di, that is the shortest distance from the capital to the ith city. Then Polycarp begins his journey in the city with number S, and being in the ith city, chooses one of the following action. Travel from the ith to the jth city. If there is a road from the ith to the jth city and distance I is less than or equal to distance j, travel from the ith city to the jth city. There is a road from the ith to the jth and di is greater than or equal to dij. Stop traveling. Okay. Since the government of Berlin does not want all people to come to the capital, so Polycarp can no more than once take the second action from the list. Okay. In other words, he can perform the second action 0 or 1 times. Polycarp, on the other hand, wants to be as close to the capital as possible. So, for example, if n is equal to 6 and the cities are connected as shown in the picture above, he could have made the following travels. Okay, so I'm starting from 2, I go to 5, I go to 1. So right now 2, 5, 1, 2, 5. So the distance is increasing. I decrease the distance once. Increasing. Okay. 3, 6, 2. So the distance is increasing, the distance is decreasing. Okay. So basically we want to find the minimum value for each city. Minimum. So basically for every I want to find the closest I can get to the capital. Okay. So since we can only use the second option once, I'm very tempted to use like a 2n DP or a 2n graph. Basically 0 would denote that I have used option 2 0 number of times, and a node comma 1 would denote that I have used that option once so far, right? So basically then what I could do is I could construct the reverse. No, I don't need to construct the reverse graph, right? I have this graph. If I can also find the di values, that is the shortest distance from the capital in this graph originally. And now what I can do is I can add edges from I to j. If di says in dj, then I can add it to the same type of node. Otherwise, I can add it to the increasing node. And okay, yeah. I think this line of thinking is correct. Now what I want to do is I want to find from every city the closest city that I can reach. Okay, so how do I do that? Okay. So basically, if I had a graph and I wanted to find, I have a directed graph, and for every node, I want to find what is the closest I can get to a source node, right? That is the simple question that I'm trying to solve now. So if I start traveling at this node, what is the closest that I can get? So obviously I can compress the strongly connected components into one component. I can run a DFS on this graph. Yeah, I think that's it. So no, the SCC would end up compressing this whole node. But if I had a cycle of length 4, okay, yes, it will work. Why not? Yeah, so that should work. So let's see. So I have get u comma into v. I have nm. I have some edges. So type of node, right? If type is 0, then I just return the value. Otherwise, return n plus u. Now, first I need the original graph. So that I'll let that be original graph of n. Cn nm for int I equal to 1, I less than equal to m I plus plus in uv Cn uv. Okay, and for the part of the recording that I missed in between, like I don't know when it turned off between problem A to problem C, I will try to re-record or explain that part at the end of the video. But anyway, let me try to finish this question first. So I have g of u dot pushback v, it's a directed graph, and then I can directly do a BFS, so I can just copy paste my template. So let me just do a BFS and store the distances, right? So I have this already. So I do visited of I is equal to 0. I can also, okay, let this be simple. I don't need this. I don't need the number of ways of getting to a particular node. I don't need this. Yeah. Okay, so now I have the initial distance of every node from a particular source node. Yeah, I think that is enough. And obviously distance of k is equal to 0. So I do, first let me also clear the initial graph. So I have g of I dot clear, I have og of I dot clear. Og of I is the original graph, so basically what I want to do is I want to push it back into og, and over here I want to write it over the original graph. So what I can do is I can do BFS from one node. Now I also need these edges, so let me just store them. So I have all of the edges. I can iterate over all of these edges now. And basically what I'll be doing is I'll be constructing a new graph. So let me see what happens. So I have u to v edge. First I'll find out distance of u, which is the distance of u, and I have dv, which is distance of v. If du is less than dv, then I can simply add an edge from u to v, right? In both of the graph, like for both of the copies of u to v. So I have g of u. Okay, sorry, I need to do this till 2 into n, and this should be 45. I think I need to erase this. Yeah, so I have g of get of u comma original dot push back get of v comma original. Okay, and similarly get the, in either of the graphs I can continue to travel, but if this is not the case, the only way I can travel is I can go from a 0 node to a 1 node. I'll explain this in detail after the contest. First I'll just check that what I'm thinking of and what I'm trying to do is correct. So in this new graph, I want to basically start a BFS, right? So let me just see, like in this case, what I can do is I can go from 4 to 2. No, I cannot go from 4 to 2, sorry. Let me consider this, yes. So I started 3, I started 6. So I cannot do this twice. I can go here and I can stop. I cannot travel in the opposite direction. Basically, I have a new graph, right? And in this new graph, I want to find the distance of no, not the distance. I think I need to construct this graph. Like, what will happen? Let me consider a simple case. I have 1 to 2 to 3 to 4. So the distances are 0, 1, 2, 3. Now the graph that I will make is I will have 8 nodes. So corresponding to 1 to 2 edge, I will add 1 to 2 and 5 to 6. So let me write it down. So I have, for the first edge I have 1 to 2, 5 to 6. For the second edge, I'll also, I'm very confused. 1 second. Basically, in this new graph, what I'm trying to do is I'm starting at every node and I'm trying to go as close as one to as it is possible, right? So even in this graph, I would have had a loop. I think. Okay, let me just see what the BFS on this new graph gives me, because I'm not very sure that what I'm doing is right or not. So let me see. So basically what I'll be doing is I'll be doing BFS from the original node 0. Let this be BFS 2. That will be on the new graph. So for the new graph, I will have 2 into n nodes, and I'll start at a particular node. I'll do the same thing that I do, and then also while doing this, I'll store the answer. So okay, so let me reinitialize the answer for every node. That will be answer of I equal to 29. Now what I can do over here is, if it is less than equal to n, answer of it is minimum of answer of it comma distance of it, else answer of it minus n is equal to min of answer of it minus n comma distance of it. I'm not completely sure that this is correct. I don't think it should be, but let's see. What happened? Okay. For node 0. Okay. So I have answer of k equal to 0, obviously. So it is what? I have a small loop from 1, 2, 2, 1. Yeah, so from 2 I can reach 1. So the answer should have been 0, but since I'm starting a BFS from node 1, I'm saying that the answer is 0, which is obviously wrong. Yeah, that is exactly what my concern was. But I think a brute force recursion where I store the answer for every node should definitely work. Yeah, I don't know why I'm doing all of this. So basically what I want to do is in DFS from int u, it may get stuck in a loop. Basically, in my new graph, the edges are of weight 0, right? So I have connected components, and for every connected, I don't even say it's a connected component because it's a directed graph. What is the closest reachable node? I'm not sure this will work, but I'm going to try it anyway. So For every node, I'll try to store the minimum ones that I can reach to, right? So I basically initialize this with -1. Sorry, int and distance is equal to answer of u. If distance is equal to -1, then if distance is not -1, then I can return the distance. Otherwise, I'll initialize distance with distance of u. Okay. Not okay. No, this is the bad idea. So let this be val. So what I can do is, yeah, if u is greater than less than equal to n, val is equal to distance of u. Otherwise, val is equal to distance of u minus n, and then I can recurse on all of its reachable nodes and store the minimum. So answer is val is equal to min of val comma dfs to it, and I'll store the answer, right? Yeah, I think this might be correct, but let's see. Yeah, this is giving this correct answer for sample cases. I'll submit this. Okay, nice, it passes. And now I have F left. So let's see what F is asking us. Polycarp got the following problem. Given a grid of size 2 cross n, some of its cells are blocked. You need to check if it is possible to tile all of the free cells using 2 cross 1 and 1 cross 2 tiles. Okay. Okay, so that is it. But n can be very large and the number of blocked cells are very few. And the coordinates are given to us. Okay. I hope this is not a very sorry, my mom had come in. So yeah, is there any good way of solving this question without any casework? Like, I want to analyze what are the cases where the answer is not possible. So let's see. Like, the first thing that comes to my mind is, suppose these black, like suppose for every black cell I consider the previous 2 rows and the next 2 rows, and basically suppose I mark those, like not those rows, those particular columns, right? So I have some columns that I want to consider. So for this case I would say that I'm considering the previous 2, that is only one in this case, and the next 2. So basically I'm trying to form components. For this component I'm saying that for this black cell I'm saying that previous 2 columns might be needed to handle this black cell. Similarly for this black cell I'm saying that the previous 2 or the next 2 columns might be required. And after forming components, basically the size of the components would still be O of m, because for every m I'm taking at most 4 extra columns. So basically I'm taking 5m columns, right? Now among those 5m columns I need to check if it is possible or not to construct the grid. And my claim is that I don't need to consider columns that are very far away. Why do I think this? And how do I prove this rather? Sorry. Yeah. Yeah, so I have x, I have x dot. So basically this requires me to put AA like this. And because of this AA, I need to put BB. And then it continues, I think, right? I don't think there is any way to stop this until I encounter the next x, which should be in a bottom cell. Okay, yeah, so basically if I have an opening cell somewhere, I need to get a closing cell in front of it. Yeah, I think that is it. And if two cells in the same column are blocked, I don't think it makes any difference. Yeah, I think that should be sufficient. Let me see. Okay. Yeah. So I have n cross m grid and I am taking some cells, block cells. So xy is blocked, block dot pushback, x comma y. I want to sort them by the column, right? Yeah, so probably I should take this as y comma x, and for the same column I want to sort them by the row. Yeah, so I'll sort this vector. I don't think it needs to be global because we'll need to clear it otherwise. So I'll just take it over here. And now what I want to do is, for n equal to 1, n equal to 2, all of them, the answer exists, right? The problem occurs when I have a blocked cell. So let me consider the blocked cells in an increasing order. So I'll say that my mask is 0. And okay, so now I come to this. Okay, so basically what I'll try to do is, yeah, let me see. So I'll iterate through the blocked cells, right? I have x is equal to it dot second, y is equal to it dot first. I don't think the y values are important, so I just need the x value. And if my mask is 0, 0, I can I think I need to implement this in a better manner. Yeah, so basically what I can instead do is, suppose I have map of int comma int mask. So what I'll do is mask of y or equal to 1 shifted x minus 1. I think that makes more sense. And now I can iterate over the masks. So in current it will be 0, and then I iterate over the masks. So now I am at some column and I have a previous mask. If my previous mask is 0, 0 or it is 1, 1, right? Then I can have 0, 0 right now. Look, okay, I will never have 1, 1. So 0, 0 denotes that all of the cells are like the previous grid is valid. Otherwise, I need 1, 0 denotes that it is valid. 1, 0 means that the next one should be 0, 1. And 0, 1 means that this should be 1, 0 or 0, 0. It cannot be 1, 1, right? Yeah. So if current is 0, then what I can do is current or equal to IT, and if current is equal to 3, then I make current equal to 0. This I will always do. So basically if it is 1, 1, I can always make it 0, 0. Otherwise what I need to do is, I need to ensure that else if current and IT is true, then that means that there is some overlap, which is wrong, right? Or can it be handled? Suppose I have up and I have up over here. I will put this, I put this. Then I'll put this cell. I had this, so I put this cell. So even that is valid. Okay. So basically, the distance between them should be odd, right? And if it is occurring over here, the distance should be even. Okay, so int y is equal to 0. So if current is 0, here if it is greater than 0 and then it is less than 3, right? Then in that case I need to store that the previous y was that this value becomes my previous y, right? it dot first, it dot second is the mask. Else, okay, so in the else case, if current is 1, then it is not possible. It is not possible, right? Yeah, if current is 3, it is not possible. So I just need to print yes or no, right? So yeah, I have bool flag is 1. In this case, it is not possible, and I break out of the loop. Otherwise, if current is equal to the mask, so if I have the same mask, that is, if I have same mask, then this distance should be odd. So if it dot first minus previous y mod 2 is 0, then flag equal to 0 and break. Otherwise, current is 0. And if it is in a different column, then the distance needs to be odd. It needs to be even. So basically, in this case, I'll print -1, and otherwise, I'll just reduce it to 0, and I'll continue forward. Yeah, things is fine. So let me just add this here. So if flag is true, I print yes. Else, I print no. Sorry, this should be admin IT.second. I don't use blocked anymore. Yes, no. Okay, wrong answer. So there are 3 Indians and 2 of them had wrong answers on F. Was it wrong answer on test 2? Yeah. So what is the issue in this? Okay, shit. So in the end, if current is not 0, right? If current is there, then also flag is 0. My bad. That was a very, very stupid mistake, and hopefully this gets AC now. Okay, doesn't. Why? Okay, so suppose I have a 1 cross 1 cell and I block one of the cells which is at 1,1, suppose again. If I block both of them, how is input given? Row and column. Okay. So I have, yeah. Wait, what? Okay. Suppose I have 2 cross 2. I block the first row in the first column and I block the second. Okay, so if we see second row, second column, the answer is no. Okay, if I block this, okay, no, but basically second column I block the first row. It gives me yes. Just this. Okay, shit. If current was 0 over here, I could have just moved on, but if current was 0, then I would never encounter it. Yeah, that's not possible. So I have current equal to 1 or 2 or 3. If it is same, then the difference needs to be even. 2, 3, 4, 4 minus 2. If it is even, then it's wrong. Yeah. Yeah, I don't get why this is wrong. It's a pure implementation question. Mask of y or equal to 1 shifted x minus 1. And clearly here x is different, there is no repeated input. I have also stored the previous index that I found it at. And if my current ever becomes equal to 3, I make it 0. I don't get it. So suppose I block the first two columns and then I ask, the answer is yes. If I block another cell, suppose this, answer becomes no. If I block the second row of the second column, the answer is yes. What if I don't block the middle two? I already checked this. The answer is no. I don't even have anything global. I feel that I'm missing something. So suppose I block this cell. At the very end, my flag needs to be this, right? I had it that condition, I hope. Yep. So suppose I have a 5x2 grid. Suppose I have a 5x2 cell, right? I have a 2x5 grid and I block 2 cells. I block the first row, second column, and I block this, which is second and fourth column. Answer is yes. If it is the fifth column, the answer should be no. If it is the third column, the answer should be no. If it is the second column itself, the answer should be yes. So, what is the issue? I don't know what I'm doing wrong. Oh my god. This should have been IT.second. What the fuck? I can't believe I wasted 10 minutes, 11 minutes in that and 2 wrong submissions. 21 minutes of penalty.